Hello, this is part 2, naming ionic compounds. In our last video, we learned that we needed to have our periodic table polyatomic ion sheet handy. We learned how to write formulas. Now we're going to learn how to name ionic formulas when you're given the formula, and we're going to provide a name for it. Okay, initially we learned to name formulas that contained one metal and one non-metal element, and the rules were pretty simple. When naming an ionic formula, you would name the metal ion first, and the second word in the compound name is the non-metal ion name, who's had the ending changed to an IDE suffix. Okay, we have to update that to include a little bit more information that we learned. So our updated rules are, we're going to name the cation or positive ion first, using a Roman numeral if necessary. And the second word of the name is the anion name. Now, the anion could be a monoatomic or single non-metal element name that ends with an IDE suffix, or it simply could be the name of a negatively charged polyatomic ion. Okay, so here's our first example. How do you name MgO? This is a metal, non-metal compound. So here, the metal ion name would be named first, followed by the non-metal ion name ending with IDE. So this formula would be magnesium oxide. Okay, here's a new formula. Ba parentheses ClO2, close parentheses. This contains a polyatomic ion. Does this change the name? Well, yes. You would still name the metal ion first, but since the anion is polyatomic, you would simply use the polyatomic ion name as the second word in your formula. So this formula would be barium chloride, because barium is the name of the metal ion and chloride is the name of the polyatomic ion. So now would be a good time for you to try some practice problems. Hopefully that seems pretty easy. Is there a catch to that? Well, unfortunately, there is one complicating issue regarding transition metals. Now, you might remember that from first semester. Okay, transition metals, like the elements that I've outlined here in the B groups on the periodic table, have the capability of making more than one form of ion because they can lose some or all of their valence electrons. Remember, we're going to have our handy test periodic table that has a reference list of the most common transition metal ions, and you're always going to be allowed to look at that and reference it for a test. Okay, notice that some of the ions have more than one charge. We have 2 cobalts and 2 manganese ions, 2 lead ions, etc. You'll always get to use this for reference, but you do have to remember to look at it. Now, here's an example that you might remember. Name the formulas PbO2 and PbO. Both are correctly written formulas, but if we followed our simplest rules, then we would name them both lead oxide. And that seems like a dangerous thing to do in chemistry. Now, we have a solution to fix this dilemma. So here's our rules update for giving names to ionic formulas. The rules are for naming, name the cation or positive ion first. The second word in the name is the anion name. If it's a single element or monoatomic anion, that name will end with the IDE suffix, or you would simply use the correct polyatomic anion name. Roman numerals should be used in a name to designate a metal cation with more than one charge state. The Roman numeral should follow the metal in the name. You can almost think of the Roman numeral as being kind of a middle name for the compound. So let's try that again. Name PbO2 and PbO. If I check my transition metal chart at the top of the periodic table, I will find that there are 2 different leads. Lead 2 with a positive 2 charge and lead 4 with a positive 4 charge. Okay, for each of these ions, I've been given a middle initial, if you will, or Roman numeral to differentiate the ions from each other in a compound's name. So let's try that again. Name PbO2 and PbO. That means that one formula is lead Roman numeral 2 oxide and the other is lead Roman numeral 4 oxide, but we have to know which one is which. So we're going to have to do some reverse thinking and think about how the formula was written in the first place. To find out which is which, let's go back and look at the formulas. Okay? So if we need more information to decide which one is lead 2 oxide and which one's lead 4 oxide, let's look at what ions could have potentially been involved. We have the choice of lead 2 with a positive 2 charge and lead 4 with a positive 4 charge. In both cases, oxide ions would be a negative 2 charge. Okay, if we had gone through the process of doing ion crisscross, then the first pair of ions would have given the formula Pb2O2. And the second pair of ions would have given the formula Pb2O4. Both of those formulas would have needed to be reduced to lowest terms. So Pb2O2 would have reduced to PbO, and Pb2O4 would have reduced to PbO2. Okay, Pb2O2 reducing to PbO would have been named lead Roman numeral 2 oxide, and PbO2 would have been lead Roman numeral 4 oxide. In most cases, it will be very easy to tell which Roman numerals used because the N subscript on the anion will match the Roman numeral. The only time you really have to be careful is if your transition metal has a charge possibility of positive 2 or positive 4. In that situation, you would need to be careful. So this would be the most complicated ionic formulas to write with Roman numerals. Okay, remember the subscripts following the nonmetal symbol in a binary formula represent the charge number of the metal. In most cases, the N subscript will reveal which Roman numeral will be used in the name. I must caution you, Roman numerals are very special case situations. You only have to use Roman numerals in ionic formula names that use transition metals that have more than one ion charge. Otherwise, it's considered redundant and you wouldn't use them. Let's take a minute to try a few formulas using Roman numeral metal charges and polyatomic ions to see our understanding.